So we're continuing solving the beam. The beam that's on the board. We have been able to get that reaction A is equal to 3 kilonewton. Reaction B is also equal to 3 kilonewtons. Now we have to now calculate bending moment, because the essence of all this working on a beam is to be able to analyze the beam, get the type of stresses, what stresses, that is the kind of actions and effects, the stresses in the beam. That stresses in form of bending moment, shear force, or normal forces that is in the beam. It is these stresses that is in the beam that we are going to, if we want to design the beam, we design against those stresses. We try, because what is the design? Design is dimensioning, trying to get appropriate dimension for the structural components in order to be able to stand the effect of the action in form of load. That is, and for us to get those such dimension, we have to first of all get the type of stresses that is in the structure like this beam. We must get the type of stresses like bending moment, shear force, or normal force. We get them before we'll be able to design this beam. If we don't get those stresses that's in the beam, we will not be able to design it, because we have to get what the dimension is to, the design is to get appropriate dimension of the structural member in order for the structural member to be able, based on its strength, to be able to carry the load. So let us get the stresses now. The first stress we're going to get is bending moment. Let's calculate bending moment along the beam. As I said earlier, bending moment is force times perpendicular distance. I want to take now bending moment at reaction at point A, support A. Bending moment at point A is 0. M at A is equal to 0. The reason is that if you look at the type of support A, the type of support, that support doesn't have resisting moment. It doesn't resist bending moment. So if the moment there is equal to 0, it doesn't resist bending moment. No matter how you load it, it will collapse, but it can't resist bending moment. So that means at A, point A, the bending moment is 0 by just this type of support. So if we move, let's see whether we can get bending moment at point, let's say this is point C. To get bending moment as to point C, there are a lot of procedures to do this, but watch this procedure. I will say, let's put the moment at C. The moment at C, because for you to take bending moment, you must start from somewhere. In this case, we are starting from reaction A. We are starting from point A. You must start from somewhere. Start taking moment. At point A, we started. The bending moment there is 0. Now we can move to another point in between here and get the bending moment. But let's come to point C. At point C, please put the bending moment at point C. Let it be looking at where you started, which in this case point A, something like this. Let's put it looking at A. That's the moment at C, looking at A. It's not there, I just put it to show. So I would say that moment at C, because that's the moment I'm looking for. Moment at C, looking at A. I say it's positive. I decide to call it positive because moment is directional. If you call it positive, anyone against it is negative. Anyone with it is positive. So I decide to call it positive. M at C, looking at where I started. So if M at C is positive, then any other moment before C that is against it will be negative. One of them that's against it is moment caused by reaction A, because as I told you, what is taking moment is converting forces to moment. And how do you convert a force to moment? Just by multiplying the force by perpendicular distance.